Greetings to everyone. I am Vedant Naik, currently pursuing Masters in Construction Engineering and Management at CEPT University. My student code is PCM23425. This studio focuses on integrated construction practices, emphasizing a collaborative approach among project stakeholders to enhance coordination and efficiency for the integrated project delivery. The studio highlights the integration of building information modeling for detailed modeling, clash detection, and streamlined processes, alongside lean construction principles like last planner system to minimize delays and optimize scheduling. As a part of ICP Studio, we have taken the commercial building project. For that, we have implemented integrated project delivery based on the studio goals and objectives. So, let us dive into the process. Beginning with the project brief, site was located at a golden triangle of city's very busy crossroad. The typology of the project is commercial building of G plus 10 stories with 3 basements which consist of showrooms and offices. The total site area of the project is 6,140 square meter with a total built up area of 43,714 square meter. The estimated construction cost is 94 crore. Further moving with the scope of work considered for the modeling and studio work is for architectural and LOD 350 model. We have done modeling for 3 basement and ground floor, and for LOD 400 and services model the scope considered is the ground floor. Moving further with the employer's information requirement. So after describing our studio's aims and objective to the client and contractor, we have collected what is their specific requirements from our side. Based on that, EIR majorly focused on visualization of massive floor height as we have 14.5 feet height of some floors, visualization of facade colonial architectural elements, site logistic layout optimization and visualization as we have space constraints over site, progress tracking of construction using lean approaches, and the 4D simulation using use case and construction process. As ICP Studio is based on the collaborative approach and collaboration between various stakeholders of the project, we have done the role play of different consultants among our group of 3 members. Based on that, I have played a role of structural, mechanical and electrical consultant. For that, I have done the modeling of LOD 350 and LOD 400 model and also done the quantity takeoff for the same. Also, as a lean champion, done the LPS tracking and lean implementation for the project. Moving ahead with the level of development versus level of schedule. LOD is basically a detail of BIM elements at different stages of a BIM model, and LOS classifies the scheduling and sequencing information as per the BIM model. The process followed for the LOD versus LOS is firstly we define the model element author, then we assign the author to appropriate LODs, then prepared the schedule and made the LOD versus LOS table, under which the table on the left showcase the model element authorization for which this is the example of architectural model. As for example, wall is the model element. For that we have modeled two categories. One is ASA blockwork and other is curtain walls. The author for that is architect and that element is targeted in architectural LOD 350 model. For that, author is architect which is denoted by A and all the other consultant is the user. The table on the right showcasing the LOD versus LOS where the detailing of model element is linked with the model delivery schedule. The whole process is done for each and every model of different streams. The table displayed here are for example only. For the 3D modeling, as per my role, I was responsible for preparation of 3D models for structural and ME discipline. The first rendered image shows the structural LOD 350 model and also the zoomed image shows the curvature part of the building. For the LOD 350, elements like column, slab, beam, shear walls and ramps were modeled with their accurate size and shapes, and also the material specification was assigned. The LOD 400 structural model consists the reinforcement detailing for the ground floor, where the accurate reinforcement detailing was done for each dia of bar with the hooks, chairs and stirrups. For the electrical model, LOD 300 model was prepared for the ground floor. The elements modeled for the same were cable trays, conduits, lighting fixtures, and distribution boards. The rendered images for the same are also presented. From the prepared models, we have done Revit quantity takeoff and compared it with the manual quantity which we have calculated from drawing, under which this is the quantity takeoff for the structural model. The element considered is column, slab, beam, shear walls, staircase and ramps, and the concrete quantity is calculated for all the three basement and the ground floor. The table shows the quantity comparison of manual and Revit quantity. The major variation is observed at the basement 1 roof slab level due to the complex level difference. Also from the graph, it can be depicted that the major variation are in column and beam, which is 9% and 12% respectively. The reason behind this variation is the human error in the manual quantity calculation, as there is the level difference in the basement 1 roof slab level and beam depth is varying, which is shown in the section of AutoCAD drawing given there, due to which there is the difference in the beam depth on the outer side of the building. But we have calculated the manual quantity keeping the depth of the beam uniform throughout. So from this comparison, it can be seen that manual quantity takeoff is time consuming and prone to the human errors, and which could lead to cost overrun for whole project, where Revit quantity is accurate and can be calculated quickly as compared to the traditional approach. Further moving with the site layout optimization, we have modeled the current site condition to visualize the space utilization over site. And based on the observed critique in the current condition, we have suggested the proposed layout. As discussed earlier, there is space constraint over site as the site is bit congested. The less steel storage space is the major issue on the construction site, as there is only 112 square meter space is available for the steel storage, due to which there is no dia-wise segregation of bar, and also frequency of ordering is more, which is currently 11 days, which sometimes leads to unavailability of steel when required. So for the corrected suggestions, firstly we have done the quantity takeoff of steel required for the each typical floors from the LOD 400 model. And as per the data collected from the site, in a year, approximately 7 typical floors can be casted. So based on that, we have derived the annual steel requirement, which is 873 metric ton, which is considering the 5% wastage. Based on the annual requirement, we have calculated the economic order quantity, which help us to replan the steel storage space based on the minimum steel ordering quantity, and also increase the frequency of ordering, which is also leads to reduce ordering cost of steel. So based on EOQ, we have recommended the minimum ordering quantity of 50 metric ton, which is currently of 35 metric ton, and also proposed the steel storage at a different location, which is shown in the layout, to increase the storage space to 350 square meter, which can facilitate minimum 4 nodes of steel rack and increase the ordering frequency to 19 days. As a part of lean implementation, we implemented approach of last planner system on site, collaborating with the contractor to track the construction progress. The process followed for the same was to understand the objective of the project and preparation of a master schedule by work structuring, which was further simplified into phase schedule. Taking into consideration the current site status, the forecasts and sequencing work we thought could be done, the look ahead schedule for 6 weeks was prepared. By pool planning and sizing work we knew that could be done, we made the weekly work plan, after the execution of which the PPC was tracked and the constraints were marked that could be used for improved planning in the further weeks and also for similar nature of project in the future. As depicted in the pictures, we started off by discussing among ourselves and taking it to the site and tracking commitment of the task completed. An example of which is as shown in the table below with the constraint faced. The green color in the table shows the planned activity, yellow shows the activity which is completed on time, grey used for the activity completed late but within the week, and the pink shows the carry forward activity which is not completed in the previous week. The PPC for each week is calculated using the formula as stated on top left corner. The PPC for each weeks are shown in the graph and number of planned, delayed and completed activity within each weeks are also shown in the table. From the PPC analysis, it can be inferred that the overall PPC were good for the site as they are majorly planning their work on the tacit knowledge. But some variants were observed and which is also categorized, which is unavailability of steel due to space planning issue and unavailability of concrete due to quarry strike. RMC plant were shut in the city. From the variance category, major variance observed is steel unavailability on site, which is also a major constraint identified as that is also delaying the preceding activities and also affecting the project timeline. Also, we have implemented LPS for our studio and the design delivery schedule. So moving further with the design LPS, the first graph shows the PPC for the each week of the studio. The PPC of week 6 is less because of suspension of classes due to heavy rainfall in the city and no input sessions were conducted. In week 9, PPC was declined due to lack of clarity in the reinforcement modeling. The graph below that shows the weekly PPC of each consultant. The individual PPC for structural and ME consultant is also shown by graph. The major reason for drop in PPC for the structural consultant in week 2 and week 9 is incomplete data in drawing as sections were not available and doubts in the modeling sequence as the software was new to the consultant. The 0% PPC of ME consultant is in week 2, 4, 5, 6 and 9 is because only the activity of collection of drawings were assigned in that week, but the actual consultant of the project was not giving the AutoCAD drawings. Some major constraints throughout the design LPS tracking are as stated, which is lack of clarity, software incompetency, unavailability of drawings, incomplete data in drawing, and the delay due to predecessor activity. Moving forward with the 4D simulation, on site there is difficulty in visualization of junction of curved beam and non-linear column from the 2D drawings for the labors. So based on that, the simulation of whole construction activity from reinforcing, shuttering, staging and concreting for that curved part was prepared for better visualization and understanding. For that, assembly of couplog system with verticals, ledgers, U-head, GI runners and 12 mm plyboard is used for slab and beam. And assembly of steel formwork with panels, tie rods and wing nut is used for column, which is same as used on site. This 4D simulation in synchro helps in enhance understanding of precise geometry, intersection and reference points and accurate dimension to labor. The scanner to view the 4D simulation is also provided. Concluding with the key learnings, through this studio I have gained critical insight into various assignments. From the level of detail versus level of schedule, this progressive standard improve coordination, cost estimation and accountability compared to static traditional methods. From the 3D modeling, detailed models and Revit adjustments strengthen collaboration and enable stakeholders to work with the greater clarity. Further, with the quantity takeoff, BIM-based automation enhance accuracy and efficiency, reducing error which is common in manual calculation. From site layout optimization, real-time adjustment and BIM tools streamline logistic, improving on-site efficiency over static planning. As from the last planner system, by integrating tacit knowledge into documented schedule, LPS reduces delays and rework, a critical challenge which is in traditional approach. From the 4D simulation, this visualization align construction sequences, fostering better stakeholder engagement than traditional Gantt chart approach. This learning shows that BIM isn't just a tool, it is a major shift, making ICP a superior choice for efficiency, adaptability, and collaboration in modern construction projects. In traditional construction practices, fragmentation often limits collaboration, coordination, and efficiency. The integrated construction practices approach, powered by BIM, bridges these gaps, offering holistic solutions that enhance project outcomes. Through these practices, the studio provides a comprehensive framework for achieving efficient project delivery, aligning design, technology, and management into cohesive process. Thank you.